Hello everyone. Today I would like to doing some presentation, but before we go into study, let me introduce myself. My name is Helen Kezia Nofitri Siahaan with NEM 2023-32035. In this video, I will explain my completely analysis and sentiment analysis experiment, but I will not simply read the code, but I will walk you through the story behind this project, how the data was processed, how the model was built, why the final accuracy reached 64.5 to 2%, and how I analyze the model using new unseen tweets. I already open up in here. I'm using Google Colabs to doing this presentation, and I just open up the dataset. This dataset I use contains 14,640 tweets, and each tweet is labeled as negative, neutral, or positive. Because Ireland passenger component load in Twitter, which is the tweets, the dataset is naturally imbalanced. And this imbalance becomes important later when we analyze why the model only reaches 64.52% accuracy. So in here, I already loading the data set. I'm using Mount Google Drive, which is the from data set. When you want to import data set from the Google Drive, I have a better idea before this one because I'm using the ASLab code before, but it doesn't generate anything. So I'm using my way, I think, using file path, and then you need to come to the Google Drive, open up the data, and share the link. But first, you need to meet up the link being sent to each other. But for the better one, you need to, when you share the link, it said you need to settings about people seen. You just need to choose one of them. It was the can be edited. So the Google Colab can help you to edit the data and open up all of the data. How can it can be open to CSV? We just need to copy paste in here and exchange this one with export y format equal CSV, and it will be voila, making it CSV. Because the later on it can be open up. I'm using it for many times, but it can be. I'm using this, and I know this because I'm using it at another lecture. So we will be learning about the first one, the clean text function. In here, mm, I'm using, wait a minute, we need to know first about the PD, why I'm using PD and all of this one. So I'm loaded the dataset using pd.read underscore CCV. As you can see in here, it was pandas.pd import array from scalar model underscore selection. We import train underscore test split. And from TensorFlow class at utils, we import to categorical. Don't forget to import NumPy to see all of this one. So for the first step is to load the dataset. We using df and equal pd.read underscore CSV using file path in here, same as here. Then it will be print out the dataset. That we need to cleaning dataset. For the cleaning dataset, we use to erase the add username or the URL, which is the HTTPS, and then another character like symbols or emoji. Then we need to apply. After that, the label will be mapped like the sentiment, and will be tell you about the text cleaned. The data DF will be text cleaned, airline sentiment will be copy, and the sentiment map will be negative, neutral, or positive. Zero means negative, one is neutral, and two is positive. And the data, which is the sentiment level, will be equal to airline sentiment with the map sentiment, and it will be define the future x and the label y, which is the x is data which is the text cleaner, and the y data is the sentiment label. With num underscore classes, it was land sentiment map. The printout will be said about the total of data sample, and the data clean that already clean is how much. So in here we got the data sample. The data sample will be contains with 14,640, and the data sample cleaning is really aggressive. So obnoxious entertainment in your West face and they have. I don't really know about this, but maybe it was one of the negative. I don't know, maybe. After that, we'll be talk about the tokenizer configuration. In here, we need to export from TensorFlow class pre-processing text with using tokenizer and the TensorFlow class pre-processing sequence using path sequence. For the for for the configuration hyperparameters, we need to convert sentence into numbers, and here we using class tokenizer configure. For the first is max underscore words. It contains to equal 10,000 words. The max underscore length contains equal 100 tokens per tweet, and the OOV underscore TOK equal OOV, which is out of vocabulary token. Tokenizer converts its tweet into integer sequence. Then I will be fed a sequence to length 100 to ensure consistent input for the LSTM. Sorry. As you can see in here, it will be have three row. The first is analyze and fitting the tokenizer with using tokenizer equal tokenizer. Inside it is num words with mass words or with token, and tokenizer fit on text, which is the X. And the second step is change the text to sequence integer. We need to use sequence equal tokenizer text to sequence like you get before, and the word index using tokenizer word index. The third step is padding or make it similar to each other for the length. We need using the padded sequence. It contains sequence, max length, padding, and truncating. Oh, sorry guys, we have fifth. We have fifth row in here. The fourth is one hot encoding for the label. The Y categorical will be categorical. Sorry, we'll be using the categorical with Y, comma num classes, and the printout will be save the size of the word, the data in and the data input. For the fifth or the last step is separate the data with training and testing. As we always doing, it was X train, X test, Y train, and Y test, and it'll be got the train test split. The parent sequence, Y categorical test size, and random test will be contained in here, and will be print out as training data shape and testing data shape. For the input in here, for the total of the data is 10,100, and the data input was 14,640 rows, each with one. And the training data sheet will be got samples. It was 11,712, and the testing data sheet we got 2,928, and the label were converted to one hot vector using two categorical, which is in wait um where is it? Oh, here. Sorry. So after that, we'll be going to the center of this code, which is the model architecture with using embedding I'm sorry, dropout and dense. For LSTM model, I'm using the following architecture with sorry, embedding, LSTM layer, dropout layer, dense, and the complex. And here we need to import from TensorFlow cross models and layers. For the from the models we have sequential, and the layers we have embedding, LSTM, dense, and dropout. For the parameter embedding, we have embedding underscore dim equals 64 dimension, and the model sequential we have max words and embedding dim. For the LSTM, we have 128 units. For the dropout, we got in here the layer 3. We have dense and dropout. The dropout is zero point 0.5 and the dense is 64 with activation ReLU. And the layer 4, we had output A, which is the three neurons output, which is the softmax for 3 sentiment classes. It has dense with norm classes and activation softmax. The compilation models will be model compile with using optimizer Adam, loss categorical cross entropy, and matrix using accuracy. And the print will be talk about the all of the model. And the model boot will be input shape with Nextland, and the model will be summary in here. And it is the table, as you can see in here. It's like it was same as the here. We just need to see this one. The total number of trainable parameter is 747,267. It contains 2.85 megabyte, and non-trainable params is 0. So after knowing about that, we need to know about the training loss. So we go into the param test using training model, and here we have 5 epochs. Batch size is 128, and we're using Adam optimizer and categorical cross entropy. After using that, we print out the data test, and we got the epochs in here. We have 5 epochs. For the first epochs, we have 0.5989 is here, and the last one we have 0.6181. After knowing about that, the accuracy stayed consistently around 0.6452, which is the middle and the consistently, but this is low performance indicate underfitting. After that, we need to evaluate the data for for evaluate the model on the test set. We using the loss accuracy, which model evaluate with X test, Y test, and variables in 0. In this type of accuracy, we have this one and the loss. And we got the result in here. The accuracy is 64.52%, like I said before, and the loss is 0.8978. And this confirms the model is performing better than random, but still not ideal for real deployment. So we need to try the new tweets in here using some tweets As you can see in here, the tweets is print out the negative, positive, and neutral. Like the negative said at Delta, my bag is lost. This is the worst customer service experience I've ever had. And the positive is said my flight was on time and the staff was friendly. And the neutral is I'm waiting for my connecting flight. As you can see in here, the new tweets already contains the negative, positive, and neutral. Like the negative, it say the worst and the service experience with my bag is lost. The loss and the worst will be headline as the negative. And then at the positive tweets, it say my flight was on time and the staff was friendly. And here we need to highlight the on time and the friendly. And the neutral is I'm waiting for my connecting flight. In here we doesn't see any negative contents or positive and it was really neutral. As you can see, just maybe he or she waiting for the connecting flight and just waiting. So for the first step we need to know about the pre-process pre-process for the new data set. We're using new clean, new sequence, and new palette. And the prediction using model predict. And the third is getting the label sentiment with prediction. And the predicted class will be NPR max, and the prediction will be access equal 1. And the print will be talk about the new prediction of the sentiment. But after we already know in here, it had like negative, positive, and neutral. The new data predicts that say that all of the new tweets is negative. How can this be possible? For the this reflects clear issues. The model is biased toward predicting the negative class. Why this happens? Because the dataset contains more negative tweets than positive or neutral. And then only 5 epochs were used, not enough for deeper learning. As you can see in here, we're just using 5 in here, okay? And then the embedding layer was trained from scratch, so the model does not understand positive expression like on time or friendly stuff, as I already headlined to you guys. And then the last why this happens is because the architecture used only one LSTM layer, which may not be sufficient for capturing nonce sentiment. To achieve better performance, several improvement can be applied. For the first is train for 10 to 15 epoch. Like in here, we just need to type down the epoch will be 10 or 15. Use bidirectional LSTM, which is richer context, and use pre-trained word embedding. Explain like glove or apply class weights to balance negative, neutral, positive. Like we need to make the balance from the data to see the negative, neutral, or positive. And then the last is improve text cleaning, like handle the HTML tokens, emojis, or sentiment pairs. This improvement will help the model correctly distinguish positive and neutral tweets. Because in here, the model just knew about the negative. So we need to explain to the model which is the positive and neutral tweets. Or maybe something like no, something like input more positive or make it balanced with positive and negative, which the model will be understand about negative and positive. But when the approach will be 15, it maybe can be more deeper and known for this type of data. No need to balance the data, but you just need to set again the epoch or the LSTM. Yeah, maybe we need to try it next time, but in this video, I just will be saying about this because I need a lot of time to explain to you guys. I'm so sorry because I have a bad English in here and maybe I'm too fast to explain, but I hope you guys can understand what I'm saying. And next time, maybe we will be talk about the code and discuss why this can be possible if the apples already shift to 10 or 15 or the LSTM already made it through the conclusion, or maybe the data set will be balanced but the output still like that. Maybe we need to discuss this next time, but thank you guys for watching. See you guys in next video. Bye bye.